Come, wherein we have a who is currently the director of Colloquium. Just to briefly introduce speaker to this audience, uh, uh, graduation, post graduation, as university, and he took up a job in DRDO while he was working opportunity to pursue PhD, which he obtained and later on he had moved to he visited various places, maybe UK, Bonn, University of Bonn in Germany, uh, Korea University in Japan, for various stints from few months to couple or so, and gained a lot of expertise aspects of cooking about it. He joined the School of Environmental Sciences, Jawaharlal University, in Delhi in 2008, and continued until March 2022, after which as I told you, took up the position of the director of IIT. Professor Dimri has made important contributions towards understanding the dynamics of the Indian winter precipitation system and its linkages with the Himalayan glaciers and associated water and hydrological budget. He used multi-scale models and observations to elucidate the processes that led to the western disturbances, their relationship with topography, along with physical understanding of the associated extreme weather events. Professor Dimri is a recipient of several awards and honors, which include the Young Scientist Award, DRDO by 2020, Commonwealth Academic Fellowship, Shiksha Ratan Award by UPS Dehradun, and Grove Gilbert Award for Excellence in Geomorphological Research and Geomorphological Specialty Group of the American Association of Geographers. Dimri is a member of the Indian International Center, New Delhi. He is a fellow of the National Academy of Sciences, Indian National Science Academy, and Commonwealth Commission of United Kingdom and the Indian Geophysical Union. Professor Dimri has authored over 80 publications in peer-reviewed journals. He has had a host of students. He guided on various aspects of Himalayan geology. Today, he's going to talk to us on Himalayan weather and climate. Professor Dimri, I really welcome you all to PRL and to this colloquium.
Professor Raju, thank you. Professor Bhagwas, distinguished guests. It's my opportunity to come to PRL again, interact with various people. I am fed well food by various scientists visited lab and good food also. The session of Professor Bhagwas, I am just firstly speaking about the IIT and then I'll IIG, he has guided for 6 years officially, and still Professor Bhagwas guiding him to his components. Two of them, IIG is working with the solar research, upper atmospheric research, where research and the atmosphere, then polar and space weather data research. Primarily, IIG is known for monitoring, measuring. It started with a small reconnaissance in 2016 across 4 states in India. Later by 1840, first as a full-fledged Colaba Observatory headed by P.R. Ramanathan to be P.R. Ramanathan once. Finally, another PRL joined Saraswati Fabric the center of geological headed first time. So these are the observatories where we are having observations from Gulmarg to Tirunelveli, Central to Rajkot. Continuously, we are taking counting data right from 1830 onwards, and recent this data sites and plan has been augmented. Time and some of the data is going to determine activity of the center, Vibhav, Jaipur, very recently, we have taken this project that recorded data, not the eye observation yet, but 2020 to 1970 data we have picked up, which is more homogeneously distributed across the observatory which I had shown in the left panel. We are trying to generate a dedicated analytic data. One sample for one method is shown here for 2011 to 2020. Various statistical regression methods control are employed to see the gaps in the data, spatial gap or the holes in the data, timeline gaps in the data, and that will be filtered, pinned, kind of a generation of new time series has been prepared to come to this gridded data, which very soon will be released for all purposes. Anybody is interested, please take this data. Some work which is going on there is the South Atlantic anomaly. That's a decrease in the magnetic flux over the South Atlantic anomaly. And one of the group who is critical and simulation group is working over that. That will be a gateway for the charged particle coming into the South Atlantic anomaly, and that could lead to the hazardous energetic particles which are entering to the Earth's atmosphere. And they have reported roughly these kind of particles has come in the past 110 years from critical simulations. EGRL, the another laboratory, full-fledged laboratory in Tirunelveli, is a test bed for ionospheric research, equatorial plasma, equatorial jet. There are not many instrumentation test bed has been working and revamped now, where we kind of ionospheric, thermospheric, mesospheric coupling has been made for various kind of research. There are very observatory instruments have been helped, radio remote sensing, radar and Sunday, and so many optical remote sensing on this data, spaceborne investigation. So various instrumentation in this test bed in Tirunelveli has been placed for various kind of research. Further, there are signatures of the volcanic eruption and seismic evolution has been seen in the ionospheric equatorial plasma bubbles over the Indian region. One of the examples is the high frequency wave recently 1st to 31st January over the Tirunelveli carry system has been recorded, and has been reported that during that particular eruptions of the Himalayan volcano eruptions, how the plasma bubble over the Indian region has a onset, and how it looked like at the Tirunelveli observations, how this that layer triggered the generation of equatorial plasma bubble at Tirunelveli. Skywave radio communication, all of us move with so many kind of gadgets which are very much dependent on frequency waves. The skywave radio communication models in an estimated form has been developed. Here we are showing one example with one of the sympathetic storm which occurred over the 17th March 2015, where for a certain time the skywave communication were badly affected. That would be reproduced in certain kind of estimate models, in which we have seen that deep ionospheric electron depletion over India has occurred roughly on that night time, noon time. And that's what is being shown here, the pre-usual day, what's the kind of a condition, what happens when there's severe increase in the skip zone, when the electrons are entering the atmosphere over the region. Space weather prediction, I should not say prediction yet. We are moving for an effort. Space weather simulation, I would like to say as of now, for the framework where we are trying to look at by level models how the daytime interaction, prediction, satellite observation, MSD kind of model can be initiated. Though we are in the initial stage and we are trying to look at whatever the simulation can be made based on data available, observations available, and how we can integrate this model further to improvise, reduce the errors as far as possible. With this initiation, one set of planning has been initiated where we are trying to look at the upper atmosphere prediction observations, monitoring, real-time data assimilation, whatever available. And finally, we want to go back to the street-time data which observability has previous peak storms, current events, radar events, and few more storm events we can simulate with some synthetic kind of analysis data or possibility of assimilating this data if we could successfully simulation. One example, though it's not perfectly done, a group is working of a space weather modeling framework where the magnetosphere and ionospheric interaction for one particular simulation of the 31st March 2001 model result to the geometric storm has been shown. Here we can see the polar cap potential during the geometric storm, or the potential cap potential of the polar cap has been seen here. I think space group at PRL will understand this much better than me in view of understanding this CME with the polar mass ejection, how this in space weather, how this impact is there, and that what would be one collaboration for which I understand space weather data, space weather studies by Aditya, which I was discussing with Professor Raju and Professor Dipu regarding some kind of a joint study which can be done. With this much understanding, some of the people have started moving the Planetary plasma from so Mars and Jupiter as of now, where they have contributed that how they have been from the genetic field, the strongest magnetic field, so many changes attached to the respective planets they have started. Venus. So based on this kind of comparison, we have reported that solitary wave in Mars and simulation, static simulation has shown that image generation process where observation model through simulation define how the solitary wave in Mars environment has been put. Further, this Martian magnetosphere, because of less magnetic field, there is no atmosphere in the southern hemisphere of the Mars. There is some mineral crustal deposition which brings small evolution of it based on the Levin data. That where it's reported that conclusive evidence for the entrance of high frequency waves in the Martian magnetosphere, and this is possibly important to understand the Martian atmosphere. Ionospheric seismology and volcanology is kind of a theoretically, I believe it's understood, but it is implemented with certain case study. Only limitation of this earthquake study is we can only correlate or work with the earthquake higher than the 6 Richter scale. That's when we have found that lithospheric atmospheric coupling in the real time, and it has given us a leverage of more than an hour than the earthquake horizontal wave propagation. Possibly in the future time, this kind of physics is proved. It will be very good for early warning system with acoustic and gravity wave interaction in the vertical atmosphere, where ahead of earthquake, energy travel or tsunami travel or volcanic eruptions, we can see that how the seismic role is played in interpreting the ionospheric and seismological relations. And that's what schematic diagram has been shown that how schematic illustration of Earth's field oscillations are getting generated based on seismic burst, which is impacting the vertical acoustic wave and gravity interaction, and it is leading up to the ionosphere. But those analysis can tell us the efficiency to produce the warning system possibly volcanic fume height as well. Well, this is a kind of a, I do not know how successful it is because I come from the atmosphere and I was very oftenly asked by professors that what translate cycle research. And I have argued that's not possible. Working beyond just in the vertical height, and how can we translate that sort of signature within the coupling from the sun to our atmosphere? We found that within the solar forcing, it definitely impacts the stratospheric winter climate, and Pasifying oscillation and other Atlantic oscillations are hugely impacted. By knowing the quasi-biennial oscillations character and Northern Atlantic oscillations character to the time, it will impact the equatorial monsoon, even the monsoon. Hence, changes based on circulation can be interpreted. But then there's a different school of thought also which says that solar influence are not much weighted for such kind of research. But this is a very ongoing study to see how the lower atmosphere, troposphere, complex lines are that can be involved in this kind of research. Another work in the seismological in Northwest India, we have mapped for various regions. Real-time seismic data is coming from some of these stations, not all these stations, which have been shown here. We have published a lot of seismic continuity surface seismic ruptures, rocky fault ruptures, and various publications has been done. It is kind of now pushed to the integrated geophysical work in Northwest Himalaya, gravity, magnetic, caloric, electrical resistivity, tomography. This kind of full-fledged laboratory is kind of put into function so that to map the different faults, crustal processes, structure of the study throughout integrated geophysical approach, and also to immediately focus on some of the specific Ticket Hill, Rocky Fault, and all these regions for geophysical survey. One crustal magnetic anomaly map over GDP province is prepared. I think this is one of the very huge contribution to generate the magnetic anomaly map from the IIG and neighboring areas of where the magma of Deccan Geological province has been there, and this is about to be completed. We are some instrumentation, magnetometer preparation, like environmental magnetism, that how the magnetic fossils has been our proxy to understand the oxygen minimum zone, minerability, reconstructing paleo latitude in the subcontinent. So these are some paleo magnetism studies are going on in IIG. Archaeomagnetism is now going on for taking the archaeological sample, how the paleomagnetism and all those studies are to intensity data, and that's categorically to enhance the prediction of global geomagnetic storms, field models. That's what is on the way. Balloon experiment, most probably by post monsoon on PIFR, balloon can be flown, I think, in Hyderabad facility, where we can have it can go up to 40 kilometers. I think the Jabalal Sahib was talking already this facility before. So that's what the one experiment with the meter here. We have got this is the case study. Similar study we are doing for the SSC rocket launch. For them, we are making crafting our instrument, which is waiting for the purpose, and we are in discussion with that. Recently, very recently, we have gone with the lake coding project in Los Angeles that we are looking westward the touch, and we want to see how the lake coding project, and we have just retrieved one. You can see that segment 4 of roughly 8.4 meters. I was discussing with Sanjeev that if some of the biochemical, some of the sample can be helped to IH for understanding. It's a national project, so can be, it has to be done in more analysis, dissection by various experts rather than on paleomagnetism or paleo climate reports. So these are the few research areas in Antarctic and Arctic. We are very much involved extensively from very inception of the IH. We have kind of leadership in IH, but that is more to do with leadership quality in India. So we have initiated this year one program, and one of the scientists has visited Arctic. One February parrot interferometer, one of the instrumentation section is working on that, possibly to have a the speed and temperature of measure these kind of measurement is like last stage of the development that the IHB it's a GPS network. I think somebody I was being discussed with. We are trying to retrieve this GPS information from various agencies and GRI, Body Institute of Management, have a only limited not to look at the crystal information because of their individual interest, but the vertical atmosphere, how it behaves. So these are the few things in IIT we are working at, and I request people to that's where I work, right? Climate change, Himalayan extreme weather. So this was the institute where I am heading now, and now I am kind of taking you to the specific region of Himalaya. Is very beautiful, massive, 5 and 55 million years back. It's great life. Himalayan start. This originally is not as smooth as could be. Gave rise to the valleys. It is mountainous regions, faults, lot of complex interaction that came up, and it's kind of the natural laboratory that comes up massive, comes out in the globe. And roughly after 15 million years back, when it stopped not propagating wind, that's what the Heliotropic fell better from the port, the monsoon came, and by hitting the monsoon, Siwaliks came. The various in the modern climate, which I generally work, Himalaya is a reserve of water. Now, what is a very unique place, hot biodiversity hotspot cleared from IPCC. It's a very complex picture. You look at reflection from language wherever point of view when you are boundary interacts for atmosphere and adjacent atmosphere, if I would say so. And it not only limits its interaction to the adjacent atmosphere, but simultaneously completely propagates the large scale circulation which is going across the world. And hence, the available information is very, very scattered. Yeah, this is the Himalayan topography which I am limiting to southern face of the Indian Himalayan region. And we don't have any kind of in situ observation beyond for the just in general from Indian Geological Department. Right? Most of the in situ observations of temperature, precipitation, that, and in particular the geographical distribution is such that geographical distribution of the nation is such that Himalaya includes the other countries, don't exclude in general. And that is one initiative we are starting. If you look at the dots or cross, I think we have this much data taken from various agencies, and we are trying to generate a aggregated data of temperature first using hybrid methods. Well, using the various data in situ observations plus possible satellite observations to generate for various hydrological and geological reasons. Now, this is very interesting. If you look the map here, this map, if you look, they are all resident precipitation in from three sources: Aphrodite, Japan, CC, Germany, and through UK. Regarded analysis use a synthetic data. They prepare a synthetic data using the regarded in situ observation using robust statistical method. In general, if you look at that, their main climatology looks very similar in all three graphs. But if you look very carefully, categorically about the intensity or distribution of precipitate, somewhere you will find that principle. So there is a uncertainty in the observation itself. Very often people ask, why IPCC, this happening, that happening, how it's happening, how the precipitation will go hold. So these are the very uncertain questions to answer. Can you predict cloud bursts? So they are very uncertain questions. And is lower, you see the altitudinal uncertainty. And if you look at the lower altitude, you have a more wider spread variability of precipitation, right? That's where the moisture current is started interacting with the orography. That's where the orographic forcing plays a role, resist each other, maybe because of vorticity, drag, and so many complex processes, which is the precipitation forming processes. All the available moisture in the free atmosphere does not precipitate. Only in the precipitation mechanism which forms the precipitation temperature. And when you climb up, we find the cluster at 4,000 and 5,000 meters, which is less variable. So by the time the moisture current goes up slow, so fight is already done, and moisture already won, which is climbing up into the atmosphere, and that's where the variability is reduced. But in between, if you look 3,000 meters, that's where the variability is not very well defined. It's a very critical reason. And if you look at the trend here in millimeter per day, you find that in last 30 years, up to the 3,000 meters, precipitation is decreasing. And then as we climb up, so higher Himalaya is likely getting more amount of rain than lower Himalaya. Primarily, this is because that you see the oceanic warming. It is pushing, helping, energetics is available, and by virtue of that, lot of energetics is available for moisture flow to be in higher up in the atmosphere, right? And it climbs in the higher atmosphere. So likelihood is that higher atmosphere will have more amount of precipitation that is seen from last 30, 40 years trend analysis. Right-hand side is the similar temperature analysis, which we have seen. But let me tell you, in the mountainous region, we don't have the diabatic capacity, which is generally called 9.8 degrees centigrade per kilometer, vertically degrees. It doesn't happen. I've seen in the Himalayan region, we have minus 15 degrees centigrade per kilometer, because that is getting disturbed because of the valley flow when the free atmosphere is going up. In the mountainous region, we don't have plain. So valley flows, mountain flows rather, they are interacting horizontally, and hence your energetics is different. So various modeling experiment, I tell youngsters, please don't get fascinated by model, right? Very often I am seeing most of the youngsters, they think model is a very great, fascinating term. For me, it's simply a method to solve, which is not available between one. So we have used various model technique and various statistical tests, robust statistical tests have been done. And we found that most of the model has a kind of predictability limit. Models are generally a set of parameterized equations, which is forced by initial condition and boundary conditions. And because if we parameterize the equation, we don't solve beyond the second, third order of equations. Generally, our we don't get the exact solution. So models, every model has a predictability. You cannot have 100% kind of solution, exact solution by beginning. So if you look at this graph, lower intensity event in millimeter per day are well captured in the model environment. Model physics captures the lower environment. But as the higher events comes, model is unable to capture the higher precipitation events in the model environment. Hence, the prediction of extreme events in coming time will not be easy times. None of the model are able to predict these things. Very often people say the America, UK prediction is very good, why India cannot be good, right? Because convection in the model, vertical convection, DTEZ, is not very well captured in the model, whereas the extra tropical countries, they don't have the convective flows. Monsoon is convective. They have an extra tropical flow where core frontal mass system plays a role, right? Which is not convective. Two air masses are coming and interacting with, so density plays a role. So that is the more towards barotropic. Whereas in our case, we are more towards baroclinic atmosphere, which is very, very difficult to predict in the free atmosphere. And hence, high intensity precipitation event will not be very possible. Similarly, temperature, March is able to predict. Temperature is more smart person in the modern environment, if you want to get the analysis in that. Precipitation forming mechanism is, if it is captured within the modern physics, it will able to predict correctly comparatively. But in case of temperature, this is much, much difficult, though the march of the temperature, if you look at this figure, in this march of the temperature, predicted temperature is very, very homogeneous. So it has a colder the environment is colder than the actual outside. So we are talking in the present time. So I have 30 years observation, I have 30-year model, and I can compare. In view of that, the model is much, much colder, and hence convection is not captured. For convection, you should have more heat, right? So model, when it's colder, it may not be able to capture good amount of heat which is received in the for precipitation or lifting the air mass up in the atmosphere. That's not being taken by the model. And generally model, if you look at the statistical robust distribution here, you see the mean field of the precipitation in monsoon time in particular, if I say so, it's easy to predict. You can have a seasonal mean field of monsoon prediction. But if you say that extremes to be predicted within the 120 days, it will not always be possible because of the less amount of temperature field is predicted. That's why seasonal mean very oftenly correct. Now, recently, monsoon is predicted above normal. We are talking mostly of LPA, low pressure area, which is monsoon to tomorrow, because of El Nino is getting weaker and La Nina is coming in the teleconnection form. So that is possible. But if you say that how many days precipitation will occur, it's not always possible in the coming to climate change. Climate change in our definition is future, okay? So very often it is confused from our kind of community. When we say climate change, immediately we think that we are talking future. So that is climate change for us. And that 200 years, we don't talk of 1,000 of years or 20,000 of years. If you look at this figure in coming time, northeast region will be getting drier and most of the monsoon overall will shift towards westward. If you can imagine the monsoon normal flow, right? It is coming, and that is the reason that we have, I think it's close by Banaskantha, Rajasthan, Jodhpur, Jaisalmer, all these regions are having flooding during the monsoon time because monsoon so large is getting shifted. Because it's Arabian Sea is warming more, and by virtue of Arabian Sea warming, the Arabian branch of Indian summer monsoon is splitting faster and it's moving northward faster than the Bay of Bengal branch, number one. Number 2 point, because of the available energetics, Bay of Bengal branch doesn't hook up around the Shillong Plateau. If you have seen northeast geomorphology, it doesn't hook up along the Shillong Plateau. It quickly rides over the Shillong Plateau now. And once it rides over the Shillong Plateau, it quickly turns to northeast in lesser amount of time. It doesn't go that deep in the northeast region. And that is one of the reasons, most probably, we are working on that. It could be shifting of Cherrapunji to maximum amount of precipitation because monsoon is not resting it there before taking it, not taking much rest when it moves further north. So that is the finding we have seen. We have given, we gave a theory, regreening of Thar, right, beginning of Thar, but it has not been accepted. Various counter argument is not. Now I am coming to temperature because it's very much in people want to know how it's going to happen. Generally, in monsoon time, temperature increase will not be more because available moisture in the atmosphere it dampens the temperature. It doesn't let temperature move freely because moisture and temperature is kind of intertwined very. It doesn't let go independent of each other. As temperature grows, moisture pulls it back. And hence, June, July, August is not going to be much change in Indian, South, I should not say Indian, South Asian continent. So temperature is mainly increasing in post-monsoon time, right? And higher elevations warming rate in Himalaya will be more than the lower elevations rate. I was discussing with Neeraj that why this could be the case, and he kind of gave a very good anecdote that elevation rate in lower elevation might be increasing less than the higher elevation because still there is snow available. Possibly the albedo is one of the mechanisms which is kind of reflecting back most of the atmosphere, hence the warming rate of that. But if that happens, what is going to happen is that snow line is going to come down, vegetation line is going to come down, animal species is going to come down, and we have proved in another work that pine is taking over the oak, and by virtue of pine taking over the oak, a lot of the forest fires is going to take place over the region, and that's what is reported in 10 years' time, at least over Uttarakhand, forest fire is more. We try to look at why the winter warming mechanism is explained in the model or not. We try to look into theoretical framework within the model, and we found that the cause of warming, where cloud level is going up, lifting condensation level where the cloud base forms, right? Because of warming, lifting condensation level is going to go up in the free atmosphere, and hence your moisture is getting held up more in time, and the cloud formation is delayed, and not only delayed, it's going up in the free atmosphere also. In view of this, we found that higher elevation are showing most warming during winter. That's what we had, that to beyond 3,000 meters. So that warming rate is more. And then pattern is clearly reflected in downwelling longer radiations also, which is coming down the longer radiation to the surface of the earth. Though it's very complex, it's not that we simply cut out, because not only topography is uneven, a lot of mountainous region, it has a lot of land use land cover issues. Somewhere you have snow, that is one. It has an upslope and downslope interactions of the wind that is creating one another problem at the lower surface of this. And then simultaneously, what is the exposure towards sun? That's more important to drive this kind of mechanism. So based on these few analysis, we have found that roughly 3,500 meters is happening, that is it level above which physics is entirely different, and below T500 meters in Himalayan region, physics is entirely different. They don't have a kind of a similar kind of mechanism happening as far as the warming rate is concerned. Here I'm briefly touching up the Indian winter monsoon, which some people don't agree with my this nomenclature, but this is not northeast monsoon. That's already proven. So when I say Indian winter monsoon, I'm talking about December, January, February. We have subtropical westerly jet moving at 200 hectopascal. And within the subtropical westerly jet, we have WDs found inside that. With the recent warming, what's happening, that subtropical jet, westerly jet is widening meridionally, right? When it's widening meridionally, WD has more play field to oscillate within the subtropical westerly jet when it's coming from eastern side at 200 hectopascal. So WD is picking sometime moisture, and sometimes WD not at all picking moisture. It is just remaining in low pressure area and passing by. So all the WDs are not precipitating. That's number one, right? And because of that, some of the WDs are not even passing over the Indian. They are just passing northward, because already subtropical westerly jet is elongating. That's one another problem is going to happen in northern Indian region during winter time. And particularly in lower figure, if you see here, the subtropical westerly jet is carrying the WB. This picks up moisture from here and there, because it's low pressure in this area. Wherever there's high pressure, wind will flow. Wind can be moist if moisture adds up to that. But importantly, we found that due to the warming, the subtropical westerly jet is going upward also, because there's warming underneath. And by virtue of that, WT is yielding more amount of precipitation over Karakoram region. That's what I tried to show in this schematic diagram. Jaskar, Great Himalaya, no, Irpanjal, Great Himalaya, Jaskar, Ladakh, and Karakoram. So WDs, which are rarely to reach over Karakoram in earlier time, that's why it was called as a. In last 10 decades, we found that WDs are yielding good amount of precipitation over this region, and its vertical axis also getting tilted. Very oftenly, geomorphologists and geologists ask how far the WD goes, how far Indian summer monsoon comes. So red one is Indian summer monsoon here over the Himalaya, and that Indian summer monsoon is 850 hectopascal phenomena. If you look at the monsoon dynamics, and whereas WD is 200 hectopascal, it gives precipitation from top, right? Maybe solid, maybe liquid, but in case of Indian summer monsoon, and that isotopic analysis in this case have shown that generally based on this information, we found that the Indian summer monsoon and Indian winter monsoon climatologically generally reach Chandrabhaga Basin, which is somewhere in the central Himalayas. And this is the distribution of WD, as I was telling. If you look at the last present decade, you will have a white holes there, white gaps there. And we found that in present decade, in the first time WD precipitation, if you look at December, January, February, spread in the various 10, 30 years, I think, 30 years time or 20 years time, we found in the recent decade there are more white holes, white gaps are there, which in the parallel diagram, if you look at here, so a lot of precipitation is coming during non-WD days. So far, I am not aware of from where this precipitation is coming because for this precipitation, which is non-WD precipitation, non-western distribution precipitation, you need to have moisture coming from somewhere, right? That's not been seen by us, and we're still working on it. Very oftenly, you might have heard of Karakoram anomaly. It is simple. Means that Karakoram glacier are either stagnant or growing. We try to provide with this physical mechanism that Karakoram and Ladakh are adjacent region. But what could be the genesis of this kind of philosophy? And we found that I'll not go in much detail. I'll tell you that Karakoram itself is sitting in the different condensation level. So any moisture which reaches at lifting condensation level over Karakoram, it's already 6,000 meter and above. All the moisture immediately gets dumped over the Karakoram, leading to enhancement mass and volume of the Karakoram glacier mass, which in case of Ladakh has to come down up to 2,000 meters from the lifting condensation level to atmosphere. So in between Ladakh and lifting condensation level, there is atmosphere. So hence, in case of Ladakh, where glaciers or beyond Ladakh also, glaciers are not increasing. Whereas over this Karakoram region. So we have seen the altitude, so that is trying, Ladakh is trying more as compared to Karakoram in last 30 years' time. And we gave a kind of a theoretical physics. This is a hypothesis. This is not observation. I have done with a model, as I told, where there is certain gap, you can do the process modeling. We looked at that over Karakoram, and even they also trend of skin temperature, not the temperature. Skin temperature means surface, not surface temperature. In our case, surface temperature is 1.5 degrees. The skin temperature is decreasing. So time is there. It's 450 okay. Time is there. Right. So skin temperature is decreasing, so it's defying the global warming. It isn't following the overall warming in last 30 years' time. And if it is cooling down, so whatever the snow is coming over this region, it's not going to melt. That's what the second figure shows that. So trends of snow amount, right? It's not melting off, it's growing over this region. If it is happening so, the trend of surface upwelling short wave radiation is again lifting it back. So whatever the snow is there, it is not capturing the upwelling sort of, it's letting it release in the free atmosphere, and so is the long wave radiation also. So because of this kind of a feeder mechanism, where albedo also can play a role, I believe, because of this feeder mechanism, this is again leading to the Karakoram to gain more mass, because the physics of the energy and distribution has kind of this kind of confusion. Over in Arabian Indus Basin, we found that Himalaya doesn't behave now similar. So I'm just touching out 3 basins. I have not yet done about the Northeast region. In case of Upper Indus Basin, in 2050, upper rapidity of Indus Basin will have more amount of water storage than the lower Indus Basin. Because if the monsoons more westward shift, it is going to need much amount of precipitation over this region. And that's not going to happen in the lower region of the Indus Basin. So that contribution leads to this kind of Satluj. There's no change in Satluj as far as the global warming is concerned. Temperatures are very homogeneous. Precipitation distribution is very, very similar in all the RCP models or SSP models. However, temperature is mildly increasing from 1970 to 2100, whereas there is no change in precipitation received of the Satluj Basin, 1970 to 2100 in all the available models. I will not go in talking of the different model physics. In Uttarakhand also, upper basins, we didn't find any much region. I'm quickly touching upon extremes, and I'll end with this. In last 30 years time or 20 years time, we found that extremes of probability of 200 millimeter per day has by 1.6%. As I was just discussing in one of the group that we all wash utensil at home. We have a sponge which we use for washing utensil. So this sponge, when it filled with water, so earlier time, where there was less amount of precipitation, your whole homogeneous precipitation used to take place. In present time, if you spinach that sponge at one place, right, whole water comes trickle down at that one particular point, and that's what becomes extreme. So such cases are increasing, number one. Number two, by virtue of oceanic warming, if you remember previous decades, cyclone used to hit the landfall in the Odisha coast or Tamil Nadu coast or wherever. But in present time, not only cyclone coming up to the Bihar, Jharkhand, water moisture is also supplied because ocean's temperatures are increased much, much more. Arabian headway is bringing more amount of tropical cyclone. Arabian headway warming is helping the fin letter jet to intrude much faster. So these all kind of combination of extremes have increased in the recent decades. And that's what I'm repeating this figure again, that scatter plot shows that precipitation in different models with observation probability distribution, we can do the forecast of the lesser precipitation amounts with very good accuracy. But as you go to the higher tailed precipitation amount, it will be very, very difficult. And I will try to show that with an example of cloud burst, which occurred in 13 to 14 September 2012, that bullseye kind of place shows that the moisture available in the Cosmo Day region over the Ukimat in the central Himalayan region. You can see that huge amount of precipitation has been received here. And along this line, I will try to show the simulation that how the perturbation in a convective perturbation in mountainous region is locked in the orography. And once it's locked in the orography, it goes vertically, goes vertically, and you see here in the second month, I told in my previous statement, climatologically, precipitation in the Himalayan region doesn't go beyond 3,000 meters, right? In this case, you see that this cloud burst, which is just a few minutes, rather few second phenomena here, which is growing in the second figure here, it is right up going to the 14.6 kilometer, and with a huge amount of precipitation just happening in a few seconds time. It means that convective perturbation of the cell has been locked with the orography, and with locking of the orography, it has gone up to the vertically with the atmosphere, and by virtue of the available moisture, it yields a lot of amount of precipitation. Now, the question comes, is it predictable? It's a hindcast, right? Such events of extreme is not predicted in the model physics because sometimes they don't capture. So only possibility of such events to help to the society translations early warning system. If we tend to see something in the upper stream, we can have a downstream information to be implemented. Even heat wave is going to be this year will be very bad for heat. These kind of events has to be. Similarly, the Ladakh cloud was another simulation we have done. We understood the physics, but in the case of Ladakh, I am not sure from where this amount of moisture comes when I got from Ladakh. I still do not know for this Ladakh catastrophe of 2010 when various villages were flooded off, from where that much moisture has entered to the cold desert area and in the summertime. Of course, it has to be monsoon contribution, but the monsoon track in the foothills of Himalaya is seen coming over that, but this much amount of precipitation is yet to be seen over the region. And distribution of reflectivity, all those kind of jargons can be seen, but real-time prediction of this precipitation of 15 seconds is very, very difficult to simulate and predict, and then it leads to the river discharge and all those dam discharge. As I told, in 10 years' time, your forest knocks, forest fire in Uttarakhand region has been increased almost, I think, 10 times within 2002 and 2019. And while doing this study, we found that in this belt, most of the cloudburst, most of the forest fire are happening in the belt of 1,000 meters to 1,000 meters. It's not beyond. That's where is the most of the laboratory of natural disaster is happening. Most of these forest fire, and here we find that slowly pine is taking over all, and it's becoming drier and drier in less than 10 years' time. The forest fires are flooded over this region in Uttarakhand belt. We have limited to Uttarakhand, but definitely they will have more road in Tarai and people north or east of this kind of region. Cloth is another very important glacier lake outburst floods. Now, prediction is up to certain extent possible. We can tell the vulnerability index, we can say the disaster index, but disaster risk reduction is more important because we cannot stop these extremes to happen. So DRR is the most important variable, which is likely to be taken into account for which this graph. So this estimation of the very low, medium, high, and very high hazard, exposure, and danger in the Himalayan region has been studied and carried out further. This is one of the very interesting event in the Chamoli disaster we have worked on. Disasters are now not solitary. All the disasters, in particular in Himalaya, and even in the cities also, like we have a flooding. These are basically urban flooding. This is not the flooding in true sense because of the choking of the existing sewages for the limited number of people, which is meant for the people to live, is no more valid. And there are more number of people are living, and that leads to the choking of the like Mumbai disaster 2006, Chennai disaster, and all those flooding events are primarily because. So in this case, a permafrost-driven rock fall roughly 3 kilometers, and while falling from this box, it has traveled down to 3 kilometers, and it has aimed for a warming environment. And while falling down to the warming environment, the associated rock permafrost or glacier um, snow started melting off. And when it melts, it got a lubricant, like, number one. Number two, when it is fallen at the ground, there are microseismic signatures who are also recorded. 2 days back, there was a good amount of snowfall has happened when it fallen down, this seismic signature, and this in fact brought down this slab avalanche, not the powder avalanche. So safe slab avalanche has come because this is time of February. Temperature started growing, the metamorphism is moved and species and begin the snowpack. And by virtue of this slab avalanche has come, and with rolling, it made the frequency came down with melting and stopped in the local rivulet. Temporary dam has, when dam started accumulating, it burst off, and that's where cumulatively brought the slurry which entered to the tunnel where roughly 240 deaths were recorded in NTPC tunnel because they were not prepared. They were not prepared for such disaster with this kind of morphology or this kind of permafrost is another reason. I think somebody is also working in permafrost. This is the first time in the Himalayan region we have shown that integrated climate topography of the permafrost, typical low in the for hydrological functioning and microclimate. This is the upper Indus Basin I am showing, where the permafrost is, it's a water storage, but simultaneously one rider is tagged that it's the methane emission. So if methane is limited, how much percentage of methane can add to the greenhouse gas or warming, this could be a debate because we are just looking from upper Indus Basin point of view, but a lot of Arctic in various regions, even Tamil is filled with permafrost. If this melting happens, then what kind of vulnerability to geohazard climate change will add to the permafrost? And based on the AIMML hybrid method, we have modeled the permafrost for three primary reasons: permafrost, low permafrost, and probable permafrost. Permafrost is primarily frozen rock for continuous 2 years, to less than 0 degrees centigrade. And that characterizes the permafrost over the high elevation regions. So that observation we have done. After going to IIG, I have just started looking at solar flares versus heat waves. certain kind of signatures we have seen in April 2022 variations with the heat wave, but it is just a half-cooked study. So I'm not very confident as of now because there are various implications over this region have to have taken place. And then how to and influence our climatic systems. That's what we ongoing study. Maybe if I call it more interesting than make us sure time permits me. So these are the few conclusions I think needed for the purpose. And I thank you for being here, my students. Finally, I thank PRL for showcasing my case, learned audience, and giving me an opportunity to share my work. Thank you very much.
Thank you, Professor Dimri, for giving us an overview of what is happening in IIG and also what is happening over Himalayas. We'll have time for questions. Yeah, one in the back.
Thank you, Professor Dimri, for the insights. You talked about westward shift of the Indian monsoon leading to extreme drought in northeast region and severe floods in northwest India. So how fast is this process happening? How fast is this westward shift in?
See, drought and flooding. Drought. I didn't say drought. I said deficit precipitation will occur in northeast India. Drought is altogether different mechanism. Flooding is primarily whatever the more. See, in western Rajasthan region, even 10 centimeter rain can bring flood because they have a less. In eastern side, even 500 centimeter doesn't bring flood because their geomorphology is cut out like right. So 30 years back, I have worked with late Rajesh Agnihotri, me and one of my students. We have shown this that monsoon is shifting westward, in which we have shown the dynamics and particularly spreading of the Arabian branch faster going to Delhi. If you know the monsoon system, as per the March northward propagation of monsoon due to the differential heating of land and ocean, this Arabian Sea is splitting faster and moving faster northward. So the Bay of Bengal branch is moving towards Bay of Bengal side, and it's not going much inside. So that's what we have seen. Revival of regreening of Thar Desert. So if more precipitation will be there, your agriculture is likely to come. Turning plain. Which one? Hard. Thar, the idea of telling that, which is not accepted, our idea so far, that Thar will become more green, means vegetation will come there because more rain will come there. That is the idea, but we have yet to prove that because when monsoon will give more amount of precipitation. So that is the idea actually, but we have to still prove that. But westward shift is proven. Yeah.
Thank you for the nice talk. I have a question related to, means you were talking about this cloud busting because of some perturbations which are happening. So is the mechanism of this perturbation is known, means it is not happening at the same place every time. Sometimes it is happening one place, sometimes other place. So is it known that what is the mechanism creating that kind of perturbation which can cause this?
In case of Himalayan cloud burst, these two mechanisms are must. Convective triggering plus orographic locking. If any of these two processes are not happening, cloud burst will not go. Right? This cell will move here and there. So orography blocks it. And the only passage to go is upwards because it has energetics available. Now you are talking of the convective but instability. Right? First part, orographic locking comes later. Yes, in the free atmosphere, convectivity DC, if you have a quick warming happening and some small initiation of perturbation comes in the free atmosphere, the convective cell will grow. And if it gets the moisture available, in the movement, it will get locked in the free orography and cloud burst will occur. So all things are needed. Energetics, if you say convective available potential energy, it has to have. If it doesn't have the available potential energy in the free atmosphere, it doesn't turn to the kinetic energy. So if it gets the cape or sin, convective instability both, it will come. So this is mandatory. Yeah, I understood. No, not possible. If I get to know that, I'll forecast the cloud burst. Tomorrow cloud burst is going to happen. That's the big problem. It's very localized, very localized. The reason is too big. Yeah.
But we also have to Wi-Fi. How can
Yeah. This is very good question you have asked. That why if it's a drying, so pine should not take over oak. Oak is more moist plant. It has a more micrometeorology should change. I agree with you. What happens in real time? Most of the moisture is getting not monsoon is getting westward shift. I never said that precipitation will be more over the west side. Precipitation is altogether different. That's very oftenly people mix up actually. Precipitation is precipitation forming mechanism. Monsoon is bringing the moisture, but how much of the moisture is getting precipitated is altogether different dynamics, right? It has a very convection is there. It has a glaciated cloud will be there, or the coalitions clouds will be there. They are very different mechanism. Okay, monsoon dynamics is shifting. Precipitation is not reaching up to the northwards. Though some paleo records says that monsoon precipitation has increased over the western Uttarakhand. Paleo records by trading in roughly 800 years old data. But I'm talking modern climate, 30 years. Is it the question I could answer? Hopefully, I don't know.
Thank you, Dr. Dimri, for a nice talk. The precipitation model which you showed, like this Aphrodite and this German model
Yeah.
and the UK one. UK one is way off compared to this Aphrodite and is it like because of different parameterization in the model or?
I think you're talking about.
Yeah, this one, yeah. So
These are not the model results actually.
uh,
These are the reanalysis generated by various centers.
okay.
And basically these three which I am showing, we understand is the gospel truth. But what I'm telling here, within this also, there is a lot of uncertainty in observation. So we should be very careful, in particular, if we are working on the hydrological research or glaciological. For large scale research, it's okay. 30 years, this thing. So these are compared with the model environment based on which we say that. In case of Aphrodite is much closer, yes, you are right. Aphrodite, Yatagai has done a lot of effort to collect data from all the country agencies, in situ data from right from Kabul, China, and hence and also Aphrodite, when she generated, she has used the vertical gradient calculation in her method. Because in Himalaya, it's very important you talk of the DPDZ. In horizontal plane doesn't matter. There is no change. So you are absolutely right that Aphrodite is best suited, but the only problem is Aphrodite, she refused to make it further beyond 2007.
Another thing I have to ask is like you're using the word like extreme, right? Extreme precipitation, extreme. Extreme compared to what?
Extreme compared to mean state.
Just for how long? And for how
30
long
years.
do we have this data for? So
See, in modern climatology, 30 years.
that is fine. I understand the 30-year average and you have high and
Yeah.
low.
So extreme.
So if we see like that, what I mean to ask basically that I know that in climatology you have 30 years average and then you have high and low. But like if you go, let us say if you go to 1950s or say 1900, early 1900 or say that time, can we show that these kind of extreme events are not happening? Or
I can do that, yes.
yeah, so
I can model that, yes. I can do that extreme flood. In particular, I am doing paleo flood simulations. I can tell in 1929 that the huge Kundan
Yeah,
flood
so
came in
you
Ladakh.
get an evidence of paleo floods,
Yes,
very extreme
yes.
paleo floods in the past. So what I want to understand is, like,
Yes.
when we say the current extreme events compared to today's climatological average.
Okay, you are talking a longer time
Yeah,
scale.
so we are using the word extreme in contemporary sense.
Yes.
Last 30 years.
Yeah.
So that, I think we have to qualify that with that particular
See,
thing, right?
in modern climatology, extreme meant for that in IPCC definition.
Yeah, so that's what
I know. So I got it your point. In paleoclimate PM5 community,
Yeah.
generally they talk more of the mean flow. PMIP community. CMIP
Right.
community is mostly.
I got that. Thank you.
Yeah.
On the last point, I just because of this, because Amjad and I were trying to work a little bit on permafrost, particularly from the biogeochemical aspect, from the biogeochemistry aspect, not
Yeah,
to
yeah.
the. So it's good that you have generated this map.
Yeah.
But do you know of any group who is kind of doing some sampling on that kind of region? Because one of our Inspire faculty and students, they tried to sample and they were thoroughly discouraged in a sense just because of logistics. It's very tough
Yeah.
terrain to sample.
Not only logistic,
Yeah.
there are chances of going to jail also because these are Ramsar sites.
Yeah, that's true.
So you have to be very careful. We have first incident that you cannot enter here.
Yeah,
So this is the first group which is initiated by us only with the NMHS funding project. You have to take proper permission of Ramsar site by forest officer at Leh. Second, you have to take permission for the police. That is
Yeah,
enough.
yeah, that's permission.
So here we have this Soker site, we have many samples attached where we have taken the data. Some of the data is left with me in my office also.
Yeah, I think anyway, we will talk about it later because
It's a very interesting study, but it's field intensive. But you should not worry about money. The institute has a lot of money. Universities has to look for the travel and all this. Yeah, universities has these problems. Yeah, like I had this problem.
Not, thank you. And I now request our